loop circuit. Let's say we have a circuit given like this, and here let's say we have 4 voltage sources. Like let's say we have 2 voltage sources here, plus minus 9 voltage, and then plus minus 3 voltage. Here we have 1 voltage, minus plus 1 voltage. Here we have 5 voltage right here. Then we have resistors. Let's put this one as 100 ohm resistor. Let's put this one as 220 ohm resistor. Okay, so here we want to solve for the current passing through this. Let's take the current direction as this. Okay, so here actually we can apply Kirchhoff's voltage law to find out the current. If we apply Kirchhoff's voltage law says this is 220. Okay, Kirchhoff voltage law says that addition of all the voltages in a loop is equal to 0. So let's go ahead and add the voltage together. So first, if I start with 5 voltage, since this is going from negative to positive, I put a minus 5 voltage, and then this one going from positive to negative, so that's plus 1 voltage, and then this is 220 ohm. And okay, so if current is going from here to here, according to our analysis, according to our assumption, we are assuming current going from here to here. So this one is plus, this one is minus. Here this one is plus, this one is minus. So this is 220, like V is, if you apply Ohm's law, V is equal to I times R. So I times 220. So we can say 220 I. Then here the current is going minus to plus, so that's minus 3 voltage. And then here also minus to plus, so that's also minus 9 voltage. And then here plus to minus, that is 100 I according to Ohm's law. 100 I, and these should give us 0. Now how many unknown variable we have? We have only one unknown variable. I is the only unknown variable, so we can solve for this one. Now let's add the voltages together first. So here we have minus 5 voltage, 1 voltage, and then we have 220 voltage. Okay, minus 3. Okay, let's add the small numbers together. Minus 5, minus 3, minus 8, minus 8, minus 9. That is minus 8 plus minus 9 is minus 17. Minus 17 plus 1, that is minus 16. Okay, let me do one more time. Minus 3, minus 5, minus 3, minus 8. Minus 8, minus 9 is minus 17 plus 1. That's minus 16. So minus 16 voltage plus 220I plus 100I, that is 320I. That's equal to 0. And if I go and continue here, that is 320I is equal to 16 voltage. Therefore, I is equal to 16 divided by 320, that is 1 over 20. 1 over 2 is 0.5, so 1 over 20 is 0.05. That's our current. We solve for the current. Okay, now let's actually calculate the power as well. If you want to calculate power, you can calculate power absorbed and power supplied. Power supplied are basically whenever the current goes through negative to positive, that is power supplied, and whenever the current goes through positive to minus, that's power absorbed. So from this one, all the resistors are power absorbed, and only this voltage is power absorbed and the others are power supplied, because for all the others, current going through minus to plus. So I'm gonna go ahead and remove this one. To do that, I'm gonna erase this thing. Okay, let's look at the power supplied. Power supplied. Power supplied when the current is going from negative to positive. So here at 3 voltage, the current is going from negative to positive. Power equation is given by P is equal to V times I. So here the voltage is 3. I'm gonna put 3 voltage here, P 3 voltage. So P is equal to V times I. So that is 3 times I we calculated, that is 0.05. 0.05, and that should give us, and make sure you put a negative here because the power supplied, it's going from negative to positive, so we put a negative sign for the voltage, and that that gives us negative 0.0, I mean 0.15, negative 0.15. Then at 9 voltage also, the current is going from negative to positive, so this is P9V, P9V, and again the power is equal to V times I, 9 voltage times the current, so this is minus 9 voltage because minus to plus, and the current is 0.05, and if you calculate this one, you're gonna get negative 0.45, and all of them are watts. And then we have how many more left? We have just one more left, minus to plus, that is P5 voltage. P5 voltage, let me separate this, and here we have V times I, that is negative 5 times I, that is 0.05. That's going to give us negative 0.25. Negative 0.25 watts. Okay, now we have calculated all the power supplied. Now let's calculate the power absorbed. I'm going to go ahead and erase this one. The only thing we have to remember is current. Current is equal to 0.05 ampere. Let's note that one down here. Others we can just erase. So now we are going to calculate the power absorbed. Power absorbed are plus to minus. So you can see all the resistor, the current is going from plus to minus. So we can calculate that. And also power equation, whenever we have a resistor and the power equation, we can apply Ohm's law, like V is equal to IR. Instead of V, we can replace that one with I times R. So that's going to be IR times I, because power equation is P is equal to VI. So IR times I, that is I square R. This is another equation for power derived from the Ohm's law. So if we calculate the power across 100 ohm resistor, then I square is 0.05 square times the R, that is 100, and that's gonna give us 0.025 watts. And then we have, is there anything else going from plus to minus? This 1 voltage is also absorbed because going from plus to, when the current goes through this, is going from plus to minus. So P1 voltage, for this one we can apply P is equal to VI. P is 1 voltage times the current, that is 0.05. So this is basically 0.05. And let me use a different color. Okay, so the next thing, the last thing we have for power absorbed is the 220 ohm resistor. So if I apply 220 ohm resistor power equation. For this one, we have to apply the I square RE formula. I square is 0.05 square times R, that is 220 ohm. So that's going to give us 0.55 watts. This is also watts. And here we have three power supplied. We have 0.015 negative 0.15 watts, and we have negative 0.45 watts, and then we have negative 0.25 watts. And if you add them together, you're going to get power supplied is equal to negative 0.85. So this is the whole power supplied. This negative represents supplied. And if you add all of these power absorbed together, you're going to get positive 0.85. So you can see both of them are equal, but the sign is different, like power absorbed is equal to power supplied. So this is conservation energy. Okay, and that's basically it. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.